In any plant, the day-to-day routine work is usually dialed in. It's a science. But what about the stuff that isn't routine? The one-off repairs, the tricky maintenance jobs? Well, that's where the real dangers are often hiding.
So, what really happens when you have to step off that well-worn path? When a job isn't part of the standard A to B production line, how do you manage the risks? Because believe me, they are very, very real.
Well, here's the bottom line. Your standard operating procedures just aren't going to cut it. For a task that's out of the ordinary, you need an out-of-the-ordinary plan. You need a specialized framework that's built from the ground up to manage the unexpected. So, to really get a handle on the solution, we first have to agree on what the problem is. What exactly do we mean when we say a job is non-routine?
Okay, this is a really critical distinction. Non-routine does not mean rare. It's not about how often you do it. It's about whether the task is part of the normal, documented production sequence. If it falls outside that formal process, it's non-routine, and it brings a whole different set of hazards to the table.
All right, so if that's the danger zone, how do we navigate it safely? Well, the answer is a formal system, and it's called Safe Work Practices. The easiest way to think about Safe Work Practices, or SWPs, is to see them as the master playbook for the unexpected. They give you the entire framework you need to control hazards for all those non-routine activities we were just talking about. And the purpose here is incredibly serious. The entire goal of SWPs is to prevent a catastrophic event, that sudden, uncontrolled release of hazardous energy or materials. We're talking about stopping explosions, chemical spills, or even silent killers like nitrogen leaks that can cause asphyxiation in just a few seconds. These are the incidents that lead to the worst kinds of accidents.
Now, here's where things can get a little confusing. I get it. You hear all these terms thrown around. SOPs, maintenance procedures, SWPs. They might sound similar, but trust me, they do very different, very specific jobs. Let's break it down.
So think of it like this. An operating procedure, your SOP, is your daily commute, the map for making a product. A maintenance procedure tells you how to, say, fix a flat tire. But the safe work practice, the SWP, that fills the crucial safety gap. It's the plan that lets you change that tire safely on the side of a busy highway without causing another accident.
Okay, so the SWP is the overall safety game plan. But how do you control the actual work, boots on the ground, on the day it happens? That's where the permit to work system comes into play. What you're looking at here is a permit to work, or a PTW. The best way to think of this is as a formal, documented conversation about risk. It's the final checklist to verify every single precaution is in place, and it's a signed authorization to start a very specific, high-hazard job. This isn't just more paperwork. It's a critical safety control. And when we say high-hazard work, we mean it. We're talking about things like hot work, that's welding or grinding near stuff that can catch fire. Confined space entry, where the air you're breathing could be toxic or gone altogether. Line breaking, anytime you're opening a pipe that could blast you with pressure or chemicals. And of course, control of energy, making absolutely sure a piece of equipment is locked and tagged out so it can't start up by surprise. Every one of these demands a permit to work, no exceptions.
And what's so important to remember is that the permit doesn't live on an island. It's the central hub of a bigger safety system. It connects the job safety analysis, the equipment isolation plans, any necessary certificates. It pulls everything together into one single, cohesive strategy for that one specific task. Okay, enough theory. Let's make this really concrete and walk through a real-world example to see how all these pieces are supposed to fit together.
So here's the job. A work order comes in to calibrate a pressure transmitter. Sounds pretty simple, right? But here's the catch. The rest of the plant has to keep running while this work is being done. That changes everything.
Now, look at how these layers build on each other. It's a sequence. First, the work order creates the task. Second, the team pulls up the safe work procedure. That's their high-level safety plan. Third, a specific permit to work is issued. That's the green light, the authorization for today's job. And only then, fourth, does the technician actually use the maintenance procedure to do the hands-on work. You see, each document has its own distinct and absolutely vital role.
So as we start to wrap this up, it is so important to remember the why behind all of this. These aren't just bureaucratic hoops to jump through. They are, quite literally, life-saving rules.
So, let's just quickly recap the big lessons here. 1. Safe work practices are all about controlling hazards during that non-routine work. 2. They have to be an integrated system.
The procedures and permits have to work together. 3. This stuff is often required by law. And 4, and this might be the most important, making it work is a shared responsibility. Everyone, from operators to maintenance to contractors, has to be on the same page.
This quote really says it all, doesn't it? The whole point is to create an integrated system of procedures and permits that help protect workers from hazards. It's about building layers of protection for every single person who walks onto that site.
And that really leaves us with one final, critical question. I want you to think about your own workplace. Are your safety procedures just documents that get filled out and filed away? Or are they a living, breathing system that you actually trust day in and day out to protect your people when the unexpected happens? Because that, right there, is the only time it truly matters.